1, negative 1. So we can be required to find the gradient of a given curve, which curve now is an implicit plus x cubed. This is equal to 2y. They are giving it to us at a point 1, negative 1. Still, we are going to differentiate. We know that if they want us to find the gradient, we started by proving the gradient function in the first videos, and we saw that this is dy dx. So this is going to be differentiated independently. This is 3x squared y plus d dx of this other term, which is x cubed, is equal to d dx of 2y. Now, differentiating this one, since we have done it more often, we can now just proceed. So we are going to have, if we keep 3x squared constant, differentiate y, we get a y dx plus, when we keep y constant and differentiate 3x squared, we shall have a 6x, then y. Then this is plus 3x squared is equal to 2 dy dx. We want to get dy dx, so we put all of them on one side and we factorize. So I'm going to factorize immediately. This is dy dx, 3x squared minus 2. Then when the two crosses equal signs, this is equal to negative 3x squared minus 6xy when this one crosses equal signs. So finally, we shall have our dy dx being equal to negative 3x squared minus 6xy divided by 3x squared minus 2. But now they gave us at a point, they want the gradient at a point 1, negative 1. So this is the x coordinate and this is the y coordinate. So we come and substitute, and we are saying therefore dy dx is given by negative 3. Our value of x is 1 squared minus 6 times 1, then times y, which is a negative 1. The whole of this is divided by 3. X is 1, but it is squared, then minus 2. So we shall come up with a negative 3. Then this is plus 6, because I have a negative 6 times negative 1. The whole of this is divided by 3 minus 2 is a 1. So the value of dy dx is just 3 at this point. So we say therefore our value of the tangent, the dy dx at a point which is 1, negative 1, is this. So it is going to be the same idea we use for this one here. So briefly, this is what we shall have for part B. Still the same approach, implicit functions. So we have part B, it is x squared, then tan x minus xy minus 2y squared is equal to negative 2. The point they have given us is 0, 1, and we have seen that this is x, this is y. Now this is an implicit. It is an implicit when you look at it. Then it is also having a trig identity of a tan. We know how to differentiate it. So we start by differentiating each term independently. This is tan x minus d dx of xy, then minus, since 2 is a constant, I can factorize it out. I say d dx of y squared, this is equal to d dx of negative 2. This is a product. When we differentiate a product rule, we know that we keep x squared constant, then we differentiate tan, which will give us the sec squared x plus, we keep the tan constant, differentiate x squared, which will give us this. Then minus, keep x constant, differentiate y, we have dy dx. Because of this negative I'm putting in brackets, it's going to affect. Then plus, keep y constant, differentiate this x, we get 1. Then minus 2. If I differentiate y squared, I'm going to get a 2y, but I 2 finds this 2, so it is a 4y dy dx. This is equal to 0. Differentiating a constant, negative is a constant. Now, what we have to do is put the dy dx on one side, then we put the rest on the other side. So in this case, I have my negative x dy dx. Then I also have negative 4y dy dx. This one is equal to all those values that are not having dy dx. I put them to another side, so it becomes negative x squared sec squared x. Then this is minus 2x tan x. Then we have minus y, which when it crosses, it will become minus y. When it crosses, it will become a positive y. When you open brackets here, we have a 4y divided x, which is it's a positive. This negative is going to go up to this one here. No, not really. No, it's a negative. It's a negative. This bracket ends. This bracket ends here, like that. So we have something like this. We factorize out that dy dx, which dy dx in this case is just negative x minus 4y being equal to negative x squared sec squared x minus 2x tan x plus y. Then we divide through by negative x minus 4y onto both sides, negative x minus 4y on both sides. Then we have our dy dx being equal to something like that. We can get rid of the negative, multiply it up and down such that we have x squared sec squared x plus 2x tan x, then minus y. All of this becomes x plus 4y. But they gave us a point. Put x as 0, then you put y as 1. So we say that dy dx at a point which is 0, 1 is going to be x squared. I'm putting there is 0 squared, because this is xy, 0 squared, then times this. Okay, this is going to be 0, so any value after it will go to 0. So I have sec of 0, this is squared, then plus 2 times 0, then I have tan of 0 minus the value of y is 1, and the value of this is divided by 0 plus 4 times 1. So in simplification, this is already a 0, this is a 0, so I have a negative 1 over 4, which is just a negative half water, or negative 0.25. So therefore, our dy dx at that point 0, 1 is that.